Hey everybody, in this video we're going to go over a final rule for determining an atom's oxidation number, which says that the sum of all the oxidation numbers will equal the total charge of that species. This is a very helpful rule, probably the most helpful. Let's talk about how it works with these two examples. First, MgNO32. Now MgNO32 does not have any charge written. In comparison, if you look over at ClO4, there's a charge of -1, but this doesn't have anything. So the first thing to be clear about is that the total charge of a compound like this, where there is nothing written down, is 0. And what that tells me is that if I add up all of the oxidation numbers of all the atoms in this thing, that they will add up to that total charge, which is 0. If I apply that same thing over here to the ClO4, it does have a charge written down of -1. And that means all of the oxidation numbers of all the atoms in this element have to add up to that charge of -1. So we're going to keep track of that, our totals in blue. We're going to do that beneath each formula. This is a good model to use for yourself when you are trying this on your own. Okay, so now I know the total charge of each species, 0 and -1. Let's start to figure out what these oxidation numbers actually are. I'm going to do that in a different color just to keep this as organized as possible. So all my oxidation numbers are going to be in green, and I'm going to list those out above each element in the compound. One of the first things you can go to is oxygen, because oxygen has pretty much its own rule that says it's almost always a -2. So I know that oxygen's oxidation number is going to be a -2. My ClO4 also has an oxygen, so let's get that out of the way and label it as a -2 as well. And every time I label one of these oxidation numbers, I'm going to go back beneath the compound and start keeping track of the totals, because if one oxygen is -2 and there are 4 oxygens in this compound, those 4 oxygens deliver a total charge of -8. If that doesn't make sense, you can just picture 4 different oxygen atoms. Sometimes it's helpful to draw them out. And that -2 oxidation number, let's keep it color-coded in green, that's the charge on each individual one. So -2, -2, -2. All 4 of those will add up to that total -8 that I've got written out beneath. And it's important to keep track of that as we go. Let's do the same thing over here. There are 6 oxygen atoms. 3 times 2 in the formula tells me there's 6 oxygen atoms. Each of them has a -2 oxidation number, and if each is -2, they deliver a total charge of -12. So that takes care of the oxygens. What other rules do I have that I can use here? One of the main ones is for metals like magnesium, because metals always form ions when they bond to nonmetals like NO3. And that's good news, because if you know the charge of that magnesium ion, then that charge is also the oxidation number. And magnesium's charge is +2. That means its oxidation number is also +2. We're going to label that in green above the magnesium. Beneath, we'll label the total of all the magnesiums, which in this case is just 1. And since there's only 1 magnesium, then it only delivers that total of +2. So let's keep going here to finish off this MgNO32, because I've done the easy ones, the magnesium and the oxygen. The only one in the middle that's a little bit harder is the nitrogen. There is no specific rule for, nitrogen's oxidation number, other than going back to the very start of this video. I know that all of these total oxidation numbers has to add up to the overall charge of the compound, which we clarified was 0. So you've got to think about what would the total charges of those nitrogens have to be to get all these numbers to add to 0. So a +2 and a -12, that would require nitrogen to be a +10 total charge in order for this whole thing to be 0. And then the last part of this is remembering that that +10 total is split between 2 different nitrogen atoms. Remember, there's a little subscript 2 here, which means there's 2 ends. So each individual nitrogen would be a +5 to give me that total of +10. And now I know all the oxidation numbers, +2, +5, and -2. We can take that same approach here to finish off the chlorine in ClO4 -1. There's no specific oxidation number rule for chlorine. However, I do know that all of the total charges have to add up to a -1. Since the oxygens bring in a total of -8, then the chlorine has to bring in a total of +7. And since there's only one chlorine atom, that single chlorine has all of that charge, or that entire oxidation number, all to itself, +7 and -2. That wraps it up for this video. Thanks a lot for watching.